Okay, I have a lot of slides. And I added 2 slides or 3 slides yesterday as I was listening to you, and thank you, Lila, for accommodating that and sending new versions. And I have 2 timers measuring my time. One I see right in front of me, and one you see right here. And the reason for this timer is that I'm recording my presentation. And if I leave you with no other message, I'd like to say that please, whenever you give a talk, record it using PowerPoint. It's low effort, and I have to believe it'll make it more accessible. Okay. So, unlike the previous talk, I'm not going to talk about a polished system that's actually dealing with accessibility. It's mostly ideas. That's why there's a question mark here, and hopefully we'll get some answers at the end of this workshop on the questions I'm going to raise. So, what brings me to this workshop are 2 projects. One is a completed project, and one just got started. Okay? And they both have to do with providing cyber support or technology for difficulty resolution. And I'm going to raise some questions about whether this has any relevance to accessibility or not. So the projects are not formally addressing this issue, but that's something I'd like to consider here at this talk. Okay. So like the previous speaker, we are about trying to figure out the mental state of human beings. Okay. And the mental state we're trying to figure out is whether they're facing difficulty or not. Okay. Now, there's many things you can do with this inference, and you can try to create games, for instance. But I come from a collaboration background. So my vision is that this inference is given to a collaboration environment, which lets some potential helper get to know that this person is in difficulty, and they can then use the collaboration environment to offer help. Okay. So that's the vision. This is the first project. It is complete. So we actually have some system. And so the idea here is that you can offer help opportunistically rather than at a scheduled time, as Heidi did in his online course. And here's a system that shows this working. So this person is programming, and then they see this balloon here saying that the system has inferred that they're making slow progress, which means they're in difficulty. Inference gets sent to another person, and they see a balloon saying that so-and-so is facing difficulty. Somehow by some existing collaboration technology to collaborate, and you see the end of the session here with the person being helped is thanking the person helping, and the difficulty is resolved. Okay. So that's the first project in a nutshell. Let me talk about the second project, which, like I said, just got started. So it's basically ideas. And like the first project, it involves programming. When we think of programming, we think of programming in the small, where you're actually taking an application and building it. This stuff has to do with data science. And in data science, you program applications, but you also put them together. You take some data, process it through some program, through some more programs. Maybe a human being will also be involved, and these multiple chains get composed together, and the output is a function of the composition, and that's the kind of work we are targeting. Okay, and the way to do such composition is to actually today use the command line. Okay, so the command line can be used not only to do operating system functionality, but to go and write to the scripts, direct input and output to files. So that's state of the art, state of practice at least. And a technology that's trying to make this idea go further is a cyber infrastructure. And I'm talking here about a system that we're working with called Cybers. And that provides you not only with command languages, which are traditionally known to be hard to learn, but also visual systems to compose these workflows together. Okay? And there's a trade-off involved here. The more visual the system, the more easier to use and learn it is by the typical population. And it also lacks flexibility. Okay, so as we've heard in this workshop, it's good to have multiple ways to do the same thing. So this technology provides these multiple ways. And what we'd like to do is make all abstractions easier to learn and use. Okay, so that's the goal of our project. We didn't invent Cybers, we're just trying to improve Cybers. Okay, and what's the key idea there? Well, if you look at data science, the heart of data science is machine learning. and the cyber infrastructure is trying to promote machine learning tools, how about it also start using machine learning tools, just as our previous project did, and that could then perhaps make the tools easier to learn and use, okay? And do other things too, and use some collaboration technology. So one of the collaboration technology we're building is a collaborative shell. A collaborative shell means collaborative command line. And I won't go through the details here, but the idea is that somebody's having difficulty and another person through this collaborative tool can offer help and they can resolve the difficulty. Okay. This is good, but it doesn't scale well. What if you have lots of people facing difficulties? So there's only so much human help you can provide. So we looking at automatic recommendations. Based on what others have done in the past, when somebody's in difficulty, and what others have done in the past is captured by some graph that whose thick edges showed the paths that are taken more often. And based on the paths that are taken more often, you're automatically offered a recommendation on how to resolve the difficulty. So the big picture here is that we today have cyber infrastructures and training sessions where a helper is visually aware of what people co-located are having, the difficulties people co-located are having, and then offers help to those in difficulty. Okay? And what we're doing is making it distributed so that the helper has an idea of what remote people are facing and provides manual synchronous help to them. And also the infrastructure itself offers help through what others have done in the past. Okay? That describes these two projects. I haven't even mentioned accessibility. So let's go and see whether this has any relevance to accessibility or not. Okay? So can this stuff make learning more accessible? Okay? So if you think of more accessible, you're trying to make it more accessible for those who face certain kinds of challenges that the typical population do not. Okay? And that can imply that they face certain kinds of difficulties that the majority don't. Okay? So it would seem, hypothesis, okay, that cyber support for difficulty resolution has larger impact on atypical populations. Okay? Now, what do you mean by larger impact here? We can say that there are more difficulty instances to resolve. Okay? And the second is that in each instance, help is more useful. Okay? And sort of quantify the number of instances. You can take the number of instances they didn't face difficulty in and the ones in which they did and divide and say that what the ratio is. And here's an experiment that shows you what kind of ratios we find in our experiments with the typical population. Very few difficulties are actually resolved, okay, because faced. And that's because programmers are matched to the task. But the hypothesis is that this ratio will decrease if the population is challenged in some way, especially if the instruction is not very accommodating. Okay? Now, how much impact will each help have? So in our experiments, we found that about 90% of the solutions just needed one line of fix. Okay? And in the experiments in which we did, the helper did solve the problem on their own, and the workers try to solve the problem on their own. So a problem that you face may not be insurmountable. It might be surmountable, it just takes longer than it should. And we believe that this time would reduce if the two of them work together to solve the difficulty. Okay? So what does this imply for accessibility? Or in general, it says that time spent on making fix was much smaller than the time spent on reading and understanding the problematic code. Okay? That means if you're visually impaired, you would even spend more time on trying to resolve the problem on your own. So we all know that an extra pair of eyes helps anybody, but it'll particularly help somebody who's visually impaired. Okay? That's the hypothesis. Okay? So this is based on the first project, some relationship to accessibility. Let's talk about the second. So as I said, we're working with Cybers, which has multiple ways of doing the same thing, which is good because then people can choose what they're most comfortable with. And so consistent with the accessibility principle. And now let's talk about, so we've got both commands and GUIs to create workflows. And let me just point out something, that a command like this, which takes 6 or 7 characters to type, has to be done equivalently in the visual case with multiple screenshots. Okay, you have to, and it's about 6 screenshots needed to do this. So the hypothesis is that if we are actually using screen readers to go and read these screenshots and try to understand the information, a visually impaired person would probably, if they know the command languages, I talked to Heidi and he said, look, command languages are hard for everybody. But the command languages would be more effective. So that would be an interesting study to do, that are command languages really better for the visually impaired? Okay? And that would be consistent with the accessibility principles, saying that content and navigation is accessible through the keyboard alone. Okay? What about the collaborative shell in accessibility? So we can all use help, but sometimes we need help because we didn't bother to read the documentation. Okay? And guess who's going to find the documentation even harder to read? Somebody who's visually impaired. So I would argue that this kind of help would be more effective in that case. Also, let's talk about the helper having a handicap. Okay, so we can try to, somebody who's monitoring my work can go and look at my interaction, look at my face, and figure out I'm in difficulty. But somebody who's visually impaired would probably prefer an inference from the system saying this person's in difficulty, and then they can do the magic shell command line command to help them. Okay, so that's a hypothesis I did yesterday based on what I heard. Another thing I'd like to would be great, which is not done today, is that one person could be doing the visual workflow, and equivalent command line interpretation could be generated by the system. Okay, that's even better than the captioning we talked about, which goes literally. This was at a more abstract level. So this can be the inclusive thing we were looking for, where the one person is handicapped in one way, and so they're following the commands, and the other person who's not handicapped visually can be using the GUI, and so again, such translation could allow people with disabilities to do things to help better. Okay, that's it. Automatic recommendation. Well, again, like I said, automatic recommendation, any kind of help is sometimes substitute for reading the documentation. So it would be as useful somebody who has trouble reading documentation. Also, automatic recommendation means that you have to enter fewer keystrokes, because the recommendation, you have to choose between recommendations. So somebody who has trouble providing input could potentially benefit from this technology. Okay. So I think I went quite fast, so we'll have some time for the issues. But here's my summary of the hypotheses, and I won't repeat them. About why this kind of work is not in my grant proposal, okay? Because I just find it very hard. Doing any kind of study is difficult, and if you're going to argue that this kind of technology is useful for somebody with this kind of handicap, how do you, firstly, we know it's a degree. How do you even sort of say this kind, okay? And then how do you get enough subjects? So that's a challenge. And is the answer, and I believe this is, I was been talking to people, to just do a longitudinal study on 1 or 2 people and use that field study to provide insights, rather than just do some lab experiment involving a lot of people with different abilities. Okay? And you need the study for 2 reasons. First, to see how well your system works, assuming it's inferring well. Also, to get training data. And for training data, you need even more subjects. And so how do you get training data for inferences? And maybe training data gotten from typical populations will work for those who are not typical, or maybe it will not. So that's a research question. Okay. And I'm 14 minutes, according to my time.